And welcome to 3.2. Note that this week we are looking at subtraction, and next week is multiplication and then division. In each of these cases we are going to follow what we did previously. We're going to be using manipulatives and the same sort of manipulatives. Note that with the Common Core standards we are looking at subtraction in the first grade, and in the third grade we are looking at subtraction of 3-digit numbers. You might want to pause the video now and read through the different subtraction problems. We're looking for subtraction problems that have a takeaway context. If you'll notice in problems 1 and 3, we're talking about how much we have and then losing or taking away another amount. So these would be the takeaway problems. The next type of subtraction problem would be a comparison type of subtraction problem, and numbers 2 and 5 are comparisons because we're looking at how many each one has and we're comparing and saying who has more. And then finally in problem 4 we are looking at a missing addend problem because we were trying to figure out which number is missing from the total sum. So a visual demonstration of this takeaway and comparison and missing addend are following. Here is a visual of the takeaway and its model. Here are problems, I believe they were 2 and 5, and they were the comparison models looking at how many more one has than another. And finally, problem 4, we were looking at the missing addend to try to figure out how much was missing so that we could get to the desired result, which would have been, in this case, $7. So we started with the 2 and then figure out what's missing in order to get 7. And here it is symbolically. In each of these cases we have 2 parts and a whole, and if we can demonstrate and explain subtraction to students in terms of addition, we find that statistically they learn much quicker and much easier and retain those things that we are trying to teach them. So here is a form of subtraction. We were looking at the 2 parts, 3 and 5, and the whole as being an 8, and teaching subtraction in this fashion. We need to be careful whenever we are talking about the parts and the whole, and then just to note that we're not talking about fractions. We are talking about sums as being the 2 parts, this part added with another part to make a whole. Now 0 is the additive identity, but we do not have that for subtraction because 0 minus a is not equal to a. So subtraction does not have this identity property because commutativity does not exist. And here is a statement of that fact saying the commutative property is not valid for subtraction because 5 minus 3 is not equal to 3 minus 5. And you're going to have to try to explain this to students, and it might be okay at this point to talk about 3 minus 5, 3 take away 5 in terms of money or in terms of owing somebody something, and to tell students that later on they're going to get to hear about negative numbers. Some of them will kind of grasp this almost immediately, and others you just tell them that it's okay if they don't get this because in the near future they are going to be talking about negative numbers and owing somebody something. We're going to look at a few different strategies for subtraction and some methods that have worked over the years, and you're going to want to be able to explain each of these different algorithms because not all students are going to grasp subtraction in the same way, so you have to come up with different ways to explain it. In each of these cases, we are going to be looking at 64 minus 27. Note that I would have to borrow for this problem, and we have a tens place and a ones place. And we're going to do this same problem for these different methods. For this first method, what was done was they took the 27 and broke it apart into a 20 and a 7. And they said 64 minus 7, and they got 57, and then they took away the 20. So you could do it likewise. You could do the 64 minus the 20, and you could get 44, and then you could subtract the 7, and you would still end up with 37. So whichever way you broke it up, you could break it up with the 7 first or the 20 first, either way, but it's to do each one at a time, the 20 and the 7. Here's a strategy involving the number line and still breaking that number apart. You're starting at 64 and you're taking away 7, and then you're taking away 20. That's just reinforcing that same type of strategy, but also bringing into play the number line. Looking at that same strategy, but breaking it apart numerically and looking at how that process plays out, we break the 27 into 20 plus 7. Note that I could break it apart as 20 plus 7 or 7 plus 20. Either way works. I would then distribute the negative, and once I did that, I did 64 minus the 7, got the 57 again, and then minus the 20 and got the 37. Same answer, different visual. Now this particular method involves negative numbers. So a student would have to understand negative numbers in order to use this particular strategy. So this seems a bit out of order to me, but this was introduced in the text, and so I want to go through it as well. Same sort of thing, taking it and beginning at the left and saying 64 minus the 20 and getting 40. Then doing the 4, so leaving the ones place alone, doing it with the tens place, doing it with the ones place, and then working through it. So 60 minus 20 is 40, 4 minus 7 is negative 3, and then just combining that 40 and negative 3. So with that said, I don't think that this would be a very good method necessarily for a third grader that didn't understand the concept of negative numbers. Blank space in there. Write down 8 minutes. I forget where it's at if I don't. Alright, in this method for subtraction, we're using kind of a comparison type method, and what you'll be doing is you'll start with the 27. You'll say, okay, I want to get from 27 to 64, so what do I need to add to 27 to get 64, but I don't want to go over, so let's add something easy. So they added 30. Notice 27 plus 30 is 57. If you would have added 40, you'd have been at 67 and you would have been over, so this you had to have added the 30. So we're sitting here knowing that I've got the 30, and you might want to write the 30 out to the side. And then I say, okay, how do I get from 57 to 64? And that would mean I would need to add 7. So the answer is 30 plus that 7 in order to get to that next, to that final number. Here we have the number line representation of what it is that we just did. We started with 27, and then we added 30, and then needed 7 more to get to 64. If I would have looked at negative numbers, I could have said, well, I can add 40 and then go backwards 3, and then said 40 minus 3 is 37, which is still my answer. Now, using models for subtraction, this to me is one of the best ways to show why we are borrowing and having to break down one of these long flats into tens so that we can borrow enough in order to continue with our subtraction. So to me, using the model, then representing it with symbols and numbers, and then using the model over and over and over again is probably one of the best ways for me to that I would think to get through to students. So this is just driving home that same point that we need to understand why we are regrouping and why we are borrowing or carrying, and really drive that home as you're explaining this and showing your students, especially when you're adding. Explain to them that you're going to have to do all of this addition backwards. So let's think about, when I regroup and I make the singles into a flat and then the flat into a square, how it is that I'm going to work this when I go backwards. Everything we do in mathematics, we learn how to go forwards, and then we learn how to do everything backwards, which is always more difficult. You can think about the fact that we learn how to add, then we learn how to subtract, which is going backwards from addition. We learn how to multiply, and then we learn how to divide, which is just backwards multiplication. We learn how to work with exponents, and then we learn how to work with square roots. And in each of those cases, going forwards is much easier than going backwards. We do the same thing in calculus. We learn how to take derivatives, and then we learn how to go backwards from derivatives, which is called an integral. For those students that really like the written language, this is another way to work your problem. Sometimes I note that students really like listening to the verbal. They like to listen to what it is that you say as you're working your problem. So watch how it is that you explain, and make sure that they can relate what you're saying to the symbolism. All right, I am going to start with 5 in my second position, so that means I have 5 groupings of 6 in my flats, and I have 1 in the ones position. Notice I have 5, 1. So that's what I have represented here. I'd like to take away this 2 groups of 6 and then 2 ones. So taking away the 2 is fairly easy. In the 6, so I took care of that too, but what's hard is to take away this 2 because I don't have 2 in the ones position. So what I'm going to do is take one of these blocks, move it over to here, and bust it apart and borrow from that. So I'm taking apart that one flat. So I've taken away, I took that flat and I busted it apart. So now I'm going to take away 2 of these ones. So let me do that. Okay, so I took away 2 of those ones. The next thing I need to do, I've had the 5, 1, and now I've taken away 2 groupings of my 6 and then 2 ones. And with that I had to bust apart another flat. So this is going to give me 2 in this second position here with 5 ones, and that is how I'm going to find the difference there, and I love using the manipulatives to do this. Let's look at one of these larger problems where we have a different base. We're going to do base 8 here. You'll notice that my squares are 8 by 8s, my flats are 8 of those little 8 blocks in length, and then here are my ones. I have the number 7, 4, 2 in base 8 represented. The first thing I'd like to do, since I'm going to be taking some things away, I'm going to take away 3 of these big squares. So here we go, 1, 2, 3. So what I have now is I have now taken away 3 of those big squares in base 8. Let me mark out my 3. Okay, so I've done that. Now I have to take away 6 of these long flats, and I don't have 6 of them. I only have 4. So I'm going to have to take one of these guys over here, one of these big squares, and I'm going to have to move him, move him over to the other side and break him apart. So let's move him. I'll fill in my hole here. And I'm going to take away 6 of those long flats. So let me just go ahead and count them. 1, 2, 3, 4, 5, 6. And take away these 6 right here. So those have been taken away, and I can mark that I have now taken away 6 of those in that second position. Now I need to take away 4 ones, still an ugly situation, because what I need to do now is take one of these long flats and move it over to the other side and bust it apart. So let's make that pretty. Alright, and I need to take away 4 of them, so let me count 1, 2, 3, 4. I'm going to take these 4 and delete them, and then count and see how many I have. Looks like I have 4, 5, 6 in the ones position. I have 3, 5 in that second position, and then 3 in that big square position. So this answer would be that 3, 5, 6 base 8. Now I am using my base blocks edition from my National Library of Virtual Manipulatives by Utah State University in order to create these, and then what I do is I just snip these and then plop them down into our a slide that I'm using. So just to show you what I'm doing, I have Snagit, that's what I use, and I'm using these tools here to copy and paste. This is my pen, this is what I use to cut out with, and there's my fill tool. I'm sure you're all familiar with those, but I'm just copying and pasting and just moving things around. And the really nice thing about this fill is I can tell it that I want it to if I'm using the fill tool and I would like to change my fill color, I can just select the color from my image, and then it selects this color, and then it uses it. Like if I wanted to fill that, see, it would use that to fill those, and it makes it look like it was all part of that originally. And that's just to show you a little bit of how I'm making this particular slide. Here's yet another algorithm. Different countries use this particular algorithm, and instead of borrowing from the top number, they're borrowing it from the bottom, or they're actually adding in from the bottom. And they're adding in because they are doing subtraction. So since they're adding it in here, and since it's subtraction, it makes this bottom number bigger, and then they put it on the top. Put the 1 just like we conventionally do. So that way, instead of making this 8 a 7 as we would normally do, they borrow from here. So you'll note that they do that all the way across. And it's just another method that's used. All right, these different algorithms, here are just some of the things we need to look for when we're looking for an algorithm. We're looking for these particular characteristics for our algorithms. We want accuracy, we want it to be general, we want it to be able to use it for everything, we want people to be able to use it efficiently without too many memorized rules, and we want it to make sense. So we want it to be transparent and make sense. Here is a very common type of problem. We have a child who is subtracting 70 minus 53, and she believes that it is 23. And what you've got to learn how to do is not just explain to them how to do it right, but you have to explain why what they did was wrong. And what I would do if I were explaining why this is wrong is I would build my 70 with my manipulatives, and then I would show taking away 53. And so I wouldn't just explain to this child how to do it. I would get my manipulatives from my base blocks, and I would show them how it is not 23, and then show her how to do this particular problem. All right, and that's it for this